Hello. In this video, I'm going to talk about the material data flow extraction and simulation system that we have created to map the manufacturing networks. So the reason we have developed this tool is that there is a huge push towards moving from our traditional supply chain management system, which is more of a linear system from developing to planning to the production, and then there is some feedback if there are any disruptions. So it's basically an inventory management system rather than looking into the network in depth. But what we want to move towards is more of an dynamic systems where as we can gain an visibility into how the network is evolving with the different parts of the manufacturing systems changing. So there has to be some kind of digital core, but the question is that what function should this digital core platform perform? So what is the market need is to get into the faster visibility into any of the risks that can happen when we gain visibility into the manufacturing networks of the suppliers beyond tier 1 and tier 2. So we have to create this digital supply network that can help us build resilience by simulating different scenarios or thinking about adopting technology A versus technology B. So if you have a map of the whole network of your manufacturing system based on technology A versus technology B, it can help us see really where are the risks existing and what are the waste being generated, where are there options to actually improve on the efficiency. As per a market report, the global market for supply chain analytics tool by 2024 are going to be about 9.2 billion. And among that, the cloud-based tools have the highest growth rate, even though their share is going to be about 3.1 billion. So the cloud-based tools, which are more collaborative, is a totally unexplored market. And what we need is that we can have this cloud-based tool for the fast evaluation of options. So this is the critical gap that our technology has been built to fill by evaluating supply networks via simulation and understanding the risk of waste generation for switching for new type of feedstocks, raw materials, or different kind of technologies. So in short, what this technology does is that it automates the mapping of the inter-industry network in terms of physical flows using mechanistic models, so first principle physics-based model, process models, and a macroeconomic input-output framework. So if you have technology A versus technology B, that can be simulated on the PIoT hub, and then we can pick from the network maps, after evaluating the network maps for two different technologies, which of these technologies have a lower emissions or waste and more resilient network structure. So I'll give a quick demo of the tool here. So I'll quickly demonstrate the use of the tool. In this tool, we have developed an interface where you can upload the engineering models. So you can type a simulation name. I'm going to put biodiesel 2, and you can put any description like network of producing biodiesel to understand the dependency on different industries. And then I can upload models. So since we were also interested in the regional economy, so we have this region, but if you want to just put a particular industry name, that should be fine too. Or you can use the region of the industry where the industry is located. So this is 2012, and then I can just upload the model. So let me just say soybean production because I'm going to use the soybean model. So I'll put soybean farming. Then I can add another model. And I'll also, for the sake of the shortness of the time, I'll just demonstrate this particular system for one particular user. And this is oilseed processing. Upload an Aspen model. So I have an Aspen soybean. And I'll also put another model. So. And then I can submit the job to the server. When the job is submitted, you will get this message. And then you need to go to the output tab and you will see something like that says the processing. So to demonstrate how once the simulation is completed, what results we get. So you will get a green status like this. and I can click on the simulation completed. What we will get is we can get a heat map that basically shows what is the different industries interacting. So you can see that the fertilizer manufacturing has a huge recycling stream, which is internal, but you can also see that soybean farming has a very high input to the soybean and other oilseed processing. So that basically tells how different industries are interacting. And we can also convert it into a network view, which we have not implemented on the cloud yet, but we can do that. And then we can have a physical use table and physical supply table. And based on that, we can know what different wastes have been produced in this network. We can also see different shared models. So we can see that if people have shared models like this one, we can download and then we can modify those models ourselves and upload for our own simulation. We can also see if any user has shared results. So for example, this user Steve276 has shared their result. We can go into that and we can look at the description to use their result. So that's the quick demonstration of how this tool can automate mapping the network of the production system, and that can help us know where we can invest to actually reduce our waste or how we are dependent on different suppliers. So moving forward, in summary, this technology can help us evaluate different technological scenarios to understand how can we lower emissions and waste, but also understand the risks that a manufacturing facility can have on other suppliers' manufacturing network itself. So gaining visibility into the tier 2 and tier 3 kind of network. We can form a digital core using this cloud platform to actually do some scenario analysis and then decide which one is the best technology for us to move forward. Compared to other technologies that are existing on the market today, like SAP, SAP, which basically helps in the inventory management and a lot of supply chain management, the advantage in our tool is that we are integrating engineering-based models. So if you have a future technology, you can actually embed it in our tool and see how the network will look like in future and not just the existing one based on empirical data. And then we can also automate, which I'm not sure if SAP does, but I know that the other tools like SEMA Pro LC and OpenLC did not have, but also automation of quantifying waste and emissions just by based on the first principles model rather than relying on some empirical data correction. So at this stage, we are looking for early industrial testers and investors to scale up and build industry-specific functionalities. As this tool is a very, very generic one, we can adapt it to different types of chemical manufacturing or pharmaceutical manufacturing, but also automotive packaging industries based on the first principles model we can create with the industry partnership. With that, I would like to thank you all for attention, and I look forward to having more conversations about our MFTES and PIoT Hub too. Thank you.